Hello everyone, I am Monica from BSc Chemistry Honours Final Year. Today I am going to read a chapter Corrosion for audio visual impaired student. Corrosion of metal. When a metal are exposed to atmospheric conditions, they react with air or water in the environment to form undesirable compounds, usually oxides. This process is called corrosion. Almost all metal except the least active metals such as gold, platinum, and palladium are attacked by the environment, undergo corrosion. For example, silver tarnishes, copper develop a green coating, lead and stainless steel lose their luster due to corrosion. Corrosion causes enormous damage to building, bridge, ship, and many other articles made of iron. The corrosion is a process of deterioration of a metal as a result of its reaction with air or water environment surrounding it. In case of iron, corrosion is called rusting. Chemical rust is a hydrated form of ferric oxide Fe2O3.xs2O. Rusting of iron is generally caused by moisture, carbon dioxide, and oxygen present in air. It has been observed that rusting takes place only when iron is in contact with moist air. Iron does not rust in dry air and in vacuum. Factors which affect corrosion. The main factors which affect corrosion are: first is position of metal in EMF series. The reactivity of metal depends upon its position in the electrochemical series. The more reactivity of metal, more will be the possibility of metal getting corroded. Presence of impurities in metal. The impurities help in setting up voltaic cell, which increase the speed of corrosion. Presence of electrolytes. Presence of electrolytes in water also increase the rate of corrosion. For example, corrosion of iron in seawater takes place to large extent than in distilled water. Presence of CO2 in water. Presence of CO2 in natural water increases resisting of iron. Water containing CO2 act as an electrolyte and increase the flow of electron from one place to another. Presence of colligate protective coating. When the iron surface is coated with layer of metals more active than iron, then the rate of corrosion is retarded. For example, coating of zinc on iron prevent rusting. Electrochemical rusting mechanism of rusting of iron. Electrochemical theory of rusting of iron. The phenomena of corrosion can be explained with the help of electrochemical theory, which involves the oxidation and reduction reaction. According to the electrochemical theory of corrosion, it is believed that non-uniform surface of metal or impurities present in iron behave like small electric cells called corrosion couples in the presence of water containing dissolved oxygen and carbon dioxide. A film of moisture with the dissolved CO2 constitutes the electrolytic solution covering the metal surface at various places. The schematic representation of mechanism of rusting of iron is shown in figure 35. In the small electrolytic cell, pure iron acts as anode while cathode are impure portion. The overall rusting involves the following step. Oxidation occurs at the anode of each electrochemical cells. Therefore, at each anode, neutral iron atoms are oxidized to ferrous iron. At anode, Fe is converted into Fe2 positive plus 2 electron. Thus, the metal atom in the lattice pass into the solution as ions, leaving electrons on the metal itself. These electrons move towards the cathode region through the metal. At the cathode of each shell, the electrons are taken up by hydrogen ions. Reduction takes place. The H positive ions are obtained either from water and from acidic substance. Example: CO2 in water. H2O converted into H positive plus OH negative. CO2 plus H2O is converted into H plus HCO3 negative. At cathode, H plus electron is converted into H. The hydrogen atoms on the iron surface reduce dissolved oxygen. 4H plus O2 is converted into 2H2O. Therefore, the Overall reaction at cathode at different electrochemical reach or different electrochemical cells may be written as 4H positive plus O2 plus 4 electron 2 is converted into 2H2O. The overall redox reaction may be written by multiplying reaction at anode equation first by second and adding reaction at cathode equation second to equalize the number of electrons lost and gained. Oxidation half reaction Fe is converted into Fe2 plus 2 electron and multiplying by 2. E naught is equal to minus 0.44 volt. Reduction half reaction 4H plus O2 plus 4 electron is converted into 2H2O. E naught is equal to 1.23 volt. Overall cell reaction Fe plus 4H positive plus O2 is converted into 2Fe2 plus 2H2O. E naught cell is equal to 1.67 volt. Ferrous ions are oxidized further by atmospheric oxygen to form rust. F4Fe2 plus O2 plus 4H2O is converted into Fe2O3 plus 8H positive. Fe2O3 plus XH2O is converted into Fe2O3 dot XH2O is rust. It may be noted that salt water accelerates corrosion. This is mainly due to the fact that such water increases the electrical conduction of electrolyte solution formed on the metal surface. Therefore, rusting becomes a more serious problem where salt water is present. Prevention of corrosion. The rusting of iron can be prevented or retarded by the method given below. First, barrier protection. This is one of the simplest methods to prevent rusting of iron. In a method, a barrier is placed between iron and atmospheric air. The barrier protection can be achieved by any of the following methods. The surface is coated with paint. The surface is protected by applying a thin film of oil or grease. The metal is electroplated with metal like tin, nickel, zinc, chromium, aluminum, etc. For example, many vehicles such as cycle, motor, car made from iron sheath are protected on rusting by paints. Many iron articles are electroplated with coating of other metals. The electroplating is carried not only for achieving brightness but also to protect from corrosion. Sacrificial protection. In this method, iron is protected from rusting by covering it with a layer of metal more active than iron. This prevents loss of electron from iron. The active metal loses electron in preference to iron and goes into ionic state. Therefore, the covering metal is consumed with time, but as long as it is present on the surface of iron, the latter is not. Metal is consumed with time, but as long as it present on the surface of iron, the latter is not stated. This type of process in which rusting of iron is protected is called sacrificial protection. Zinc is now commonly used for covering of iron surface. The process of covering iron with zinc is called galvanization. The galvanized iron materials maintain their luster due to the coating of indivisible layer of basic zinc carbonates ZnCO3. Zinc hydroxides on the zinc films. If some scratches occur on the protective zinc film on coated iron, even then iron will not be rusted. This is due to the fact that because of scratches, both zinc and iron get exposed to oxidation, but zinc undergo oxidation in preference to iron. This is so because the reduction potential of zinc is less than the reduction potential of iron. Zn2 plus 2 electron is converted into Zn solid. E naught is equal to minus 0.76 volt. Fe2 plus 2 electron is converted into Fe solid. E naught is minus 0.44 volt. Therefore, zinc undergoes oxidation in preference to iron. However, it may be noted that in case of tin plating, tin coating on iron, the film will be effective as long as it is intact. When scratches occur at the coating surface, both the metal are exposed to oxygen, and iron is preferably oxidized and is rusted. This is due to the fact that the reduction potential of tin is more than that of iron. Sn2 plus 2 electron is converted into Sn. E naught is equal to minus 0.14 volt. Fe2 plus 2 electron is converted into Fe. E naught is equal to minus 0.44 volt. Thus, iron will be oxidized in preference to tin. Electrical protection. This method is used for protecting iron articles in contact with water, such as underground water pipes. The article of iron is connected with more active metals like magnesium or zinc. The active metal has lower reduction potential than iron and will lose electron in preference to iron. For example, magnesium has lower reduction potential than iron. Mg2 plus 2 electron is converted into Mg. E naught is equal to minus 2.37 volt. Fe2 plus 2 electron is converted into Fe. E naught is equal to minus 0.44 volt. Therefore, magnesium will be oxidized in preference to iron, and therefore it will protect iron from being rust. Using anti-rust solutions to retard the corrosion of iron, certain anti-rust solutions are used. For example, solution of alkaline phosphate and alkaline chromates are generally used as anti-rust solution due to the alkaline nature of these solutions. The H positive ions are removed from the solution. The rust is prevented. For example, iron articles are dipped in boiling alkaline sodium phosphate solutions when a protective insoluble sticking film of iron phosphate is formed. Thanks for all. It is the whole reading of chapter Corrosion for audio visual impaired student. Thank you.